Hello students, and welcome to section 2-3, rate of change and slope. Rate of change. So rate of change is a ratio that compares how much one quantity changes on average relative to the change in another quantity. For example, find the average rate of change for the data in the table. So average rate of change, as they describe it, is the change in y values divided by the change in x values. And it will always be written in the sense where your numerator is your difference in the output or y values, and they actually flipped it in the xy table, but that's okay. Typically the x is on the left side, not the y, not the right. Well, y is obviously on the right, not the left typically. But what we see here is easy enough to interpret still. Numerator y and denominator x. So for this particular scenario, you can see the time x in hours and the elevation of the sun y in degrees. So the change in elevation of the sun divided by, and that's the change in elevation again, divided by the change in time. So what we typically like to do when we calculate the average rate of change, which yes, later we will decipher this as our slope, and also our m value, if we recall, y2 minus y1 over x2 minus x1. Now I know I'm introducing this a little bit early, but I know you've already seen this quite a bit in Algebra 1. The numerator is your rise, this whole difference, while the denominator is your run, this whole difference. So if you take the difference in what? Picking a number here, 84, minus here 6, that's the numerator. Divide that by the change in x's, so 11 minus 7. Okay, so I've labeled y sub 2 and y sub 1 here and here, x sub 2 and x sub 1. Now if this data is representing a linear equation or function, it doesn't matter what two ordered pairs or points you can say, same thing. It doesn't matter which two you choose. It turns out that the difference in the numerator is 78, the difference in the denominator is 4, so degrees per hour. And in this case, 78 divided by 4, 19.5, and again, the units degrees per hour. It is a positive value, so over the course of time, as time increases, the elevation of the sun increases. And yes, sometimes you will get a negative slope or average rate of change. I will use slope off and on as I introduce concepts. Formally, like I said, though, we'll take a look at it on the next page. As the textbook kind of describes in the pretty much same exact manner. Okay, so number one, we have our x's more traditionally on the left, we have our y's on the right. Again, average rate of change will be the difference in the y, so I called this last y y2, I called this y1, x2 here, x1 there. So the difference in y's, 151 minus 101, divided by the change in x's, 740 minus 730. So this difference ends up being 50, and this difference ends up being 10. And we're talking about what? People per minute. So 5 people per minute. That ends up being the average rate of change. Let's take a look at number 3. Number 3 is the same basic principle. As you can tell here, we're looking at these two x's as I chose and these two y's. Same principles, y2 minus y1 divided by x2 minus x1. Now in this problem I challenge you to actually flip these two. So you do this number instead of that minus that. This number, so 1610 minus 3432. And if you do that, please though flip the denominator values as well. So instead of 28 minus 4, it's 4 minus 28. In that respect, you will get a negative divided by a negative, and it still ends up being a positive 75.9 vehicles per minute that go through this tunnel. Number 6 is a good next question to take a look at. Please try number 5 on your own. But number 6 is good because what I went ahead and did here is I asked you to calculate, or we actually went ahead in advance. I've done in the past where the students calculated the average rate of change. So I challenge you to find that, pick any 2 points, and do the same exact process of y2 minus y1 divided by x2 minus x1. Once you do that, I'm going to, again, maybe ask you to challenge yourself and think about what the slope-intercept form will look like. Again, I know you've seen this before, but I want you to kind of foreshadow what the next bit of information is going to look like. So again, here's your slope. Please check and see if you pick whatever 2 points, you pick, you end up with this particular slope, meters per second. And then ask yourself also why I'm picking this as my quote-unquote b value. Again, y equals mx plus b. Turns out this is b because, well, look at the very first point. It's 0, comma, there it is, 37.3. So test that theory and see if, in fact, you can get that same result. Let's move on. So again, speaking of foreshadowing and seeing what this next page is all about, of course, slope, or m, of a line is indicative of what we've already discussed, the change in y's divided by the change in x. Note that x1 cannot equal x2, or x sub 1 cannot equal x sub 2, same thing. Otherwise, you have a denominator here that's 0, and we cannot divide by 0 ever. So that's the obvious fraction we're going to stick to. For example 1, find the slope of the line that passes through 2, -1. I've already labeled x1, y1 for you, and -4, 5, which is x2, y2. Difference in y's over difference in x's, so I did 5 minus a -1, and I made it plus a positive to make it a little bit easier in the next step. -4 minus 2. This, of course, is 6. This, of course, is -6. Now, if you had flipped the order, in other words, if you had done -1 minus 5 divided by 2 minus -4, you would have ended up with -6 over +6. In the end, it's going to end up being exactly the same number, -1 for your slope. Okay, let's look at example 2. It says find the slope of the line. When given a graph, it is relatively nice to be able to look at 2 distinct points and simply do rise over run. No matter where you start here, it's pretty straightforward. If you start here at this ordered pair, you can go up 1, left 2. Up 1, left 2 is going to be indicative of +1 over -2 as your slope. Or instead of starting here, you can start here and go down 1, right 2. Down 1 implies then a negative, and right implies a positive. So it's the same exact result, -1/2 as your slope. If you decide, though, to use the formula exactly as you see it using these 2 ordered pairs, in context, it would be what? These 2 as x1, y1, x2, y2. So -3 minus a -2 divided by 3 minus 1 as you see. And again, this ends up being -1/2. There are some problems that I wanted to walk through with you, but I also want you to try some as well on your own. Number 1, pretty straightforward here. We've got 2 ordered pairs. I've labeled them for you. So I do here 13 minus 7 divided by 6 minus 4, of course, 6 over 2. So you get a slope of 3. Again, if you had done the opposite order, so to speak, you would have gotten a -6 over a -2. And again, that ends up still being +3. I'm going to jump down to number 10. I still want you guys to take a look at those circled questions that I've completed. But on number 10, it says determine the rate of change. On the last set of problems, it was more or less the same thing, but finding the slope as they described it using the formula. Here, you can do basically the same thing, but instead of actually using the formula, you can just do rise over run. So if we start here, go down 4, so -4, and right 5, so +5. And there you go, -4 over +5. Or if you start here, you can go up 4, +4, and left 5. So there you go, -5. Either way, those 2 answers are fairly good to write. So what we're going to go ahead and take a look at next is section 2.4. This is another combined day of work. And in section 2.4, we're going to go ahead and take a look at writing linear equations. So let's take a look. As I've already described, slope-intercept form of a linear equation, which you again remember hopefully from Algebra 1, y equals mx plus b, where m is the slope and b is the y-intercept. Point-slope form of a linear equation, y minus y sub 1 equals m times the quantity x minus x sub 1. And again, you've got m for your slope. I didn't speak to it exactly on some of the problems prior, but b again is your y-intercept. I alluded to it, of course, but on that one problem, the very first page, I guess, in section 2.3. However, it is most certainly the y-intercept, as you hopefully recall. Okay. It turns out that this form is also very useful. You can actually take this once you get the appropriate values, let's say for m, x sub 1, y sub 1, and you can manipulate it in such a way where you can rewrite it as you see up above, y equals mx plus b. All right, example 1. It says write an equation in slope-intercept form for the line that has a slope of -2 and passes through the point 3, 7. So here's your slope, there's your m, here's your point, and again this is on the line. It's 3, 7, so x and y. So as far as their description here goes, it says substitute for m, x, and y in the slope-intercept form. So y equals mx plus b again, y again is 7, m is -2, x is 3, we don't know b, we're going to solve, which of course if you do the math that's easily enough, -6, simply add 6 and there you have it. B is 13, 7 plus 6. The final answer, putting it all together, y equals our slope from the beginning, remember, was -2, so -2x, and then add your b as a finishing touch, so y equals -2x plus 13. Now if you were to graph this, and we're going to save some time here and maybe have you try this on your own later, but if you were to graph this, the y-intercept of the graph of this line is 0, 13. So once you plot the ordered pair 0, 13, from that point you can go down 2 and right 1, because this really as a slope in a fraction form is -2 over 1. So down 2, right 1. So rise over run. Example 2. Write an equation in slope-intercept form for the line that has a slope of 1/3 but an x-intercept of 5. Okay, interesting. So an x-intercept, if you recall, similar to a y-intercept but just kind of flipped, so to speak. So with a y-intercept, like I said in the last problem, it's 0, a value. In this case, the x-intercept is, well, in this case 5, but comma 0. So 0 is the y but not x. So what we're going to do, we're going to plug in 5 for x. We're going to plug in 0 for y, and again use slope as, in this case, 1/3 for m. So plugging in 0 for y, 1/3 for m, 5 for x, solve for b. This ends up being 5/3. You can subtract it over, and easily enough, b ends up being -5/3. The y-intercept, therefore, is just -5/3, and yet again you put it together in slope-intercept form, where y equals 1/3 x minus 5/3. Again, that's your m, and that's your b. Okay, and the problems that follow, they're very much like what we just saw. Number 1, for example, write an equation in slope-intercept form. Slope is -2, so there you go. I plugged it in for m. It goes through the point -4, 6, so there's your y, 6. There's your x, -4. Solve for b. This math ends up being nicely enough 8. Subtract 8. 6 minus 8, of course, is -2. Put it together. Your final answer in slope-intercept is y equals -2x, because again that's the slope, minus 2. There are some other questions that I wanted to highlight. Number 3, as you can tell, it says with a slope of 1 going through the point 2, 5, you could use y equals mx plus b like I did on number 1. However, in this particular problem, I'm going to go ahead and try out my point slope form. So y minus y1, notice I've already labeled it here, and that equals m, which is 1, times the quantity x minus, and here's x sub 1 that I've labeled, so x minus 2. Distributing the 1 is very easy here. You just get x minus 2. Simply then add 5 over. So adding 5, 5 minus 2, of course, is 3. So your final answer is simply y equals x plus 3. Maybe as a finishing touch, we'll take a look at number 5, and we will wrap this up. First, I'll ask that you maybe take a look at the rest on your own, but I'll probably wrap this up in a live lesson on another day. So number 5, you have a picture again, but you have to write the equation in slope-intercept form. So here's your, as you can see, the slope calculation. So from this point, actually this point technically, excuse me, down 6 and right 2. So -6 over 2, which of course is -3. I plugged it into y minus y1 equals m times x minus x1. There's 0. For y1, there's 3 for x1. I simplified. I didn't have to move anything over, and y equals negative 3x plus 9. This 0 made things really nice. Please finish up on your own taking a look.